The last few videos we've been looking at factoring. This one's going to be a more general type of factoring. We want to factor this trinomial. It's trinomial because it has 3 parts. It's going to factor into 2 parentheses. The beginning is the same as what we've done on the last 2 lessons. X times x gives me x squared. But you'll notice the ending, it's not a perfect square. It's not like 3 times 3 is 9 or 5 times 5 is 25. So what we have to consider is, for the endings here, what multiplies to equal 8? Well, it could be 1 and 8. It could be 2 and 4. We have to figure out what we want. One way to do it is to use trial and error. The other way is to know from this piece. I need the ones up here that will add to give me 6. That means I want 2 and 4. But I want to make that clear that this is the correct one by multiplying it back out to ensure it works. You should be getting familiar with this table method. I'm going to check it to make sure it works. X times x, x squared. We're good so far. 2 times x is 2x. 4 times x is 4x. And then 4 times 2 is 8. There's our 8. When we add these, it needs to give us a 6x. This check is not required, but it kind of makes the connection there for you. Let's look at this. Once again, you'll notice these numbers are not a square. That's what makes it the more general type of factoring. The beginning, that's part of the battle. Get it taken care of. X times x gives you x squared. Now I gotta look what multiplies to equal 15. Well, 1 and 15, 3 and 5 are the factors that come to mind. But now we have to consider you can get positive numbers by doing 2 positive or 2 negatives when you multiply. If I do 2 positives, I won't get a negative there. So we're going to need to do 2 negatives. Let's just do this trial and error method. Let's just say I want to do -1 and -15 because that is a possibility. If I come over here to my table, I'm going to show you that this isn't going to work. The x squared part will check, and this 15 part will check, but it's this part that tells us this is not right. This will give us -1x, and this will give us -15x, and when we add those together, it's not giving us the correct piece here. Go back to the drawing board. Let's try 3 and 5 this time. Do some wiping out here. We already know this part checks. We already know this part checks because of the way we set it up. We're checking for this part. -3x, -5x, and when you add it, this is what we want. A lot of people can look ahead and not need to do the trial and error. If you can do that, it'll save you some time. Here we go. XX. Well, multiply is equal 10. Well, 1 and 10, 5 and 2. But notice it's actually a -10. That means one of the factors needs to be positive, one needs to be negative. If we're doing this bit where you're looking at this, we need these to add to equal 3. Well, that's not going to work. This can work if we get the negatives to work out correctly. So I'm going to put 5 and 2 in here. And I need it to add to equal 3. Well, if I do 5 plus -2, that'll work. And if you don't think you can get the signs right, do some trial and error. Let's check it out. X plus 5, x minus 2. Should be getting real quick at the x squared part, the -10 part. Here's our moment to see if it works. X times 5, 5x. X times -2, -2x. When I add that, I get 3x. If I had swapped those around, it would have given me -3x, and it wouldn't have checked out. Our last one here. You'll notice I got different combinations of positive and negatives on each of these problems. Give you the full scope of these factoring types. I need to multiply and equal 21. I could go 1 and 21. I could go 3 and 7. Other problems could have more things to try, but I wanted to keep it somewhat limited here. One needs to be positive, one needs to be negative, because these numbers are multiplying to equal a negative. Let's try this thing where we look and we need them to add to equal -4. I can't add these to equal -4 even if I make one negative. But down here I can add them to equal -4 if I make one of them negative. If I go 3 plus -7, I'll get -4. So it's going to go +3 -7. One last check on our table. X plus 3, x minus 7. We know it's -21. We know it's x squared. Here's our finishing piece to see if it's correct. Add that, and it worked.